Hello there, folks. Today we embark on an exciting journey to the center of our home planet, Earth. Now you might be wondering, what makes this journey so thrilling? Well, let's begin by understanding the structure of our planet. Earth, our terrestrial home, is not just a solid ball of rock. It's a complex layered structure, much like an onion. The outermost layer, or the skin of this onion, is the crust. It's the solid ground we walk on every day, housing towering mountains, deep oceans, and sprawling cities. But it's also the thinnest layer, accounting for just 1% of Earth's volume. Beneath the crust lies the mantle, a thick, rocky layer that makes up about 84% of Earth's volume. It's here that the tectonic plates float, their movements causing earthquakes and volcanic eruptions. The mantle isn't just rock though, it's a hot, flowing mass of silicates, creeping at a snail's pace but capable of reshaping our world over time. Now we come to the heart of the matter, the Earth's core. Divided into two parts, the outer core, a sea of molten iron and nickel, and the inner core, a solid ball of the same metals. The core is the engine room of our planet. It's responsible for our magnetic field, protecting us from harmful solar radiation. Embarking on a journey to the Earth's core is not just about drilling a hole and hopping in. It's about facing scorching temperatures, immense pressure, and the unknown. It's a journey that no human has made, a frontier that remains unexplored. But it's also a journey into understanding our planet better, into uncovering the secrets that lie beneath our feet. So buckle up as we dive deep into the Earth's layers and uncover the mysteries of the core. First up, we have the Earth's crust, the layer we're most familiar with. This is the thin, rocky outer shell where our continents, oceans, and all known life forms reside. It's like the skin of an apple, relatively thin in comparison to the other layers. The Earth's crust varies in thickness, ranging from about 5 to 70 kilometers. Now that may sound substantial, but when you consider the Earth's total diameter is over 12,000 kilometers, you realize just how thin the crust really is. The crust is also not uniform. It can be divided into two main types, the oceanic crust and the continental crust. The oceanic crust is thinner and denser, averaging about 7 kilometers in thickness, and primarily composed of basalt. On the other hand, the continental crust is thicker, anywhere from 20 to 70 kilometers, and made up mostly of granite. Interestingly, these two crust types float on the semi-fluid layer beneath them, the mantle. They're like pieces of a jigsaw puzzle, constantly moving, albeit at a glacial pace. This movement leads to the formation of mountains, valleys, and other geographical features that make our Earth's surface so diverse and dynamic. But the crust is not just about rocks and mountains. It's the foundation for life on Earth. It's where our fertile soils form, where our water accumulates, and where the air we breathe is held. Without the crust, life as we know it would cease to exist. The crust is also where we find valuable resources like metals, gemstones, and fossil fuels. It's like a treasure trove that humans have been exploiting for millennia, shaping our civilization and our history. And yet, despite its importance, the Earth's crust is just the beginning of our journey. It's the first layer, the gateway to the deeper, more mysterious parts of our planet. Now, imagine if we could drill through this crust, what would we find beneath? Let's find out. Past the crust, we enter the mantle, a hot, flowing layer of rock. This is no ordinary rock though. It's the Earth's thickest layer, making up a whopping 84% of the planet's volume. Imagine, if you will, a layer of rock so vast it could swallow up 14 Greenlands stacked one on top of the other. That's the scale we're talking about here. Now you might be picturing a static, solid mass, but the mantle is anything but. It's composed of silicate rocks rich in iron and magnesium, and it behaves more like a very thick, slow-moving liquid than a solid. Picture hot caramel slowly rolling in a pan, and you're close to visualizing the mantle's movement. Now this is where it gets interesting. These rocks, heated by the core below, rise towards the crust, cool down, and then sink back towards the core in a circular motion. This process is known as convection, and it's the Earth's own version of a lava lamp. But these aren't just geological curiosities. These convection currents are the driving force behind the movement of the Earth's crust. That's right, the ground beneath our feet isn't as stable as it seems. The Earth's crust is broken into numerous pieces, like a giant jigsaw puzzle. These pieces, or tectonic plates, float on the mantle's convection currents, moving apart, sliding past each other, or colliding in a slow-motion dance that has been going on for billions of years. This tectonic activity is responsible for some of the most awe-inspiring and terrifying phenomena on Earth. The creation of mountain ranges, the rumble of earthquakes, and the fiery eruptions of volcanoes. So, you see, the mantle isn't just a layer of hot rock. It's a dynamic, ever-changing engine that shapes the world we live in. As we move deeper, the conditions become more extreme. Are you ready to venture into the core? Finally, we reach the Earth's core, the heart of our planet. This is where the real magic happens, where the mysteries of our world are born and sustained. The core of our Earth is divided into two distinct parts, the inner core and the outer core. The inner core, the very center of our planet, is a sphere of solid iron and nickel. It's about 70% the size of the moon and hotter than the surface of the sun. The outer core, on the other hand, is a sea of molten iron and nickel that surrounds the inner core, a seething, swirling mass of liquid metal. One of the most fascinating aspects of the Earth's core is its role in creating our planet's magnetic field. This magnetic field is generated by the movement of the liquid metal within the outer core. As it churns and moves, it generates electrical currents, and these currents in turn produce a magnetic field. This magnetic field extends far beyond the Earth's surface, into space, providing a protective shield that deflects harmful solar radiation. But the core's influence doesn't stop there. The extreme temperature and pressure conditions within the core contribute to its unique properties and behaviors. The intense heat from the core creates convection currents that drive the movement of the Earth's tectonic plates. This tectonic activity shapes our continents, causes earthquakes, and leads to volcanic eruptions. The core's pressure, on the other hand, is so immense that it squeezes the atoms in the inner core into a solid state, despite the scorching temperatures that would normally keep them liquid. This is why the inner core is solid, while the outer core, which is under less pressure, remains liquid. The Earth's core is a dynamic and complex system that plays a vital role in shaping our planet and sustaining life as we know it. It's an unseen powerhouse, a hidden engine that drives our world, influencing everything from our compass needles to the very ground beneath our feet. And though it remains buried deep beneath us, its effects are felt every day, in every corner of our world. Now that we've explored the Earth's core, you might be wondering, why does this matter? Well, let's dive into that. The Earth's core is more than just a fiery ball of molten metal at the center of our planet. It's the powerhouse that drives many of the processes that make life on Earth possible. Understanding the Earth's core is crucial in predicting natural disasters. Earthquakes, volcanic eruptions, tsunamis, these natural disasters can cause immense damage, and the more we know about the Earth's core, the better we can prepare for these events. The core's movements generate seismic waves, and studying these waves can give us valuable insights into when and where these catastrophic events might occur. The Earth's core also plays a crucial role in studying planetary evolution. By examining the core, scientists can piece together the history of our planet and even make predictions about its future. Our core is like a time capsule, holding secrets about Earth's past that are waiting to be discovered. Research on the Earth's core doesn't just benefit geologists or seismologists. It contributes to a wide range of scientific fields. From helping climatologists understand climate change to aiding astronomers in their search for extraterrestrial life, the knowledge we gain from studying the Earth's core has far-reaching implications. Not to mention, the Earth's core is responsible for creating the magnetic field that protects us from harmful solar radiation. Without it, life as we know it would be impossible. So, the next time you look at a compass and see the needle pointing north, remember, you have the Earth's core to thank for that. So, while the journey to the core might be a long and hazardous one, it's a journey worth taking for the secrets it unravels about our home planet. Thanks for joining us on this adventure, and remember to stay curious.